All right, let's try a problem. Okay, so I'm going to walk you through this one. Then we're going to do one or two more. All right, so on that same paper, I'll get that in a minute. Okay, so let's look at the question. Question says, truck A of mass 1,500 kilograms, 1,500 kilograms, is initially moving at a speed of 8 meters per second. Truck B of mass 2,000 kilograms is initially moving at a speed of 1 meter per second. Okay. Truck A catches up and collides with truck B. The two trucks become stuck together as shown in the figure. Momentum is conserved in the collision. First thing, what type of collision is this?
Inelastic.
How do you know?
They don't have the same speed.
Now remember,
Because
inelastic collision. Go ahead, let me hear what you're saying.
They didn't bounce off each other. They stick together. So I think deformation of the object occurred, so that's an inelastic collision.
All right, very good. So what tells us that this is inelastic is because we're told that the two objects stick together after they collide, okay? So this is an inelastic collision. We're not looking at the speeds before. They're going to have different speeds before, or they could have the same speed before. It doesn't matter. We're looking at what happens after they collide. That tells us what type of collision it is. If they bounce off of each other, it's an elastic collision. If they stick together, it's an elastic collision. Okay? So some other keywords that will tell you whether or not it's an elastic or inelastic. For inelastic, you may also see after collision, they share a common velocity, or they move off with a common velocity. All of those are your keywords to tell you that it's an inelastic collision, okay? For elastic, if you see words like bounce off, all right, or move in opposite directions, or if you're given the speed of if you're given the speed of one of the objects after the collision and asked to find the other, then you know, okay, they're different. That's an elastic collision, okay? Or even if you're asked to find the mass and they give you the two final speeds, once the two final speeds are different, then that's an elastic collision. Okay? So elastic collision, you see bounce off or VA2, velocity of final velocity of object A is not equal. So that sign means not equal to the final velocity of object B. That's an elastic collision, okay? All right, so now that we know what type of collision that we are dealing with, let's continue answering the question. All right, so the first thing they asked us is to calculate the initial momentum of truck A. All right, so initially we're told that truck A is moving at a speed of 8 meters per second. So 8 meters per second is this is truck A, so velocity A1. That's the initial velocity of truck A. We want to find the momentum, initial momentum of truck A. So I'm going to say momentum A1 for initial momentum of A. And that's equal to the mass of truck A multiplied by the initial speed, VA1, of truck A. Everybody with me? I'm just using my regular momentum formula, okay? So I multiply 1500 kilograms by 8 meters per second. And what do I get? Yep, 12,000. That does not look like a comma. 12000. Okay. I see nobody is giving me any units. What are my units? Awesome. Okay. So 12,000 kilograms meters per second. Okay. All right. Next part of the question. So let me clear my annotations. All right. Initial momentum of truck B now we want to find. Okay. Like I had an extra slide in there. All right, initial momentum of truck B. Well, that's just the mass of truck B multiplied by the initial speed of truck B, which is 2,000 times, easy peasy, 1 meter per second, meters per second. So that's going to give us 2,000 kilogram meters per second. Okay? Keep those values in mind. Now we're asked to find the final velocity of the trucks after they've joined. So here's another keyword that tells us that this is an inelastic collision. So you might also see joined, okay? Tells us that it's an inelastic collision if you didn't know yet. Now, I included the formula in this question, but on an exam, you're not going to get that formula. So you're going to actually have to remember this, and it's not on the formula sheet. It's not on the formula sheet either. So you're going to actually have to remember this formula. Okay? So the final velocity of the trucks after they've joined. So what we're interested in finding is V2A and V2B. But since this is an inelastic collision, we know that VA2 is equal to VB2, and so I can rewrite my formula by factoring out the common final velocity. So I'm going to rewrite MA VA1 plus MB, mass of B, multiplied by velocity B1 is equal to, wait, hold up, what we're supposed to be doing is factoring. So we're factoring out now the common velocity that we're trying to find. So I'm going to pull out V2, and that leaves behind mass of A plus mass of B. Okay. Am I done yet? Nope, I'm not done. Now I have to make my velocity the subject of the formula. So I'm going to take this entire expression, mass A plus mass B, over to the other side of the equation by dividing both sides of the equation by mass A plus mass B. Okay? Second. Now don't get lost with all the numbers. Stay with me. All right, so we cancel, and then our final formula, and you can remember this form of the equation for inelastic collision. So you can start from this point right here when you're working it out, okay? So if you're finding the final velocity, your formula is V2 is equal to all of this right here, okay? So MA VA1 plus MB VB1 all over MA plus MB. Okay? I'm going to put brackets around everything. This is the final form of our formula. Okay? Don't be too concerned if you're having issues getting from here to here. You can just remember this form of the formula for when it's inelastic collision. Okay? All right. So, to the business at hand. We're asked to find the final velocity. Well, this problem becomes very, very easy because if we recognize that we already know, we've already done half the work in the first two parts of the problem, this right here is just the initial momentum of object A, and this right here is the initial momentum of object B, which we already know the values for. The initial momentum of object A was equal to what? What was the initial momentum of object A? The first thing we calculated. Y'all done lost your calculations already? Remember, it was 12,000. Right. okay? And the initial momentum of object B was, or truck B, was 2,000. All right? And our masses, the mass of truck A is 1,500, and the mass of truck B is 2,000. So plugging in all my values nicely, I'm going up top now. V2 is equal to 12,000 plus 2,000 divided by 1,500 plus 2,000. Simplifying, 12,000 plus 2,000 gives me 14,000 all over 1,500 plus 2,000, which gives me 3,500 or 3,500. And so finally, once I divide, what's my answer? No, there's no square root. There's no square root. Okay, so our answer is 4. Can you try to make this complicated? 4 meters per second. Okay? So if we were to just say in English, what happened? Describe the collision. What happened? Well, there were 2 trucks. One truck had a mass of 1,500 kilograms, and it was moving at 8 meters per